I'm James, and I work in the aquaponics system.
I'm Jaedyn, I also work in the aquaponics system.
And I'm Daisy, I work in the NFT.
And this is our science project. A couple months ago, it came to our attention that the pH was changing rapidly throughout the systems, especially the aquaponics.
The pH is very important to a plant's growth. The pH shows how many nutrients the plant is getting. If the pH is too high or low, that means the plant is not getting the amount of nutrients it needs. We use an indicator dropper to show what the pH is. Inside the indicator dropper, there are color drops to show the exact number of the pH. If the pH is a greenish yellow like this, it means it is the right amount of nutrients for a plant to live in. It's about 6.3 to 7.0. If the pH is a dark blue like this, it means it's way too high, like 8.5, 8.0. And if the pH is a bright red like this, it means it's way too low, like 4.0 to 4.5. We knew that the pH was changing throughout the systems because one day we took the aquaponics pH. It was bright pink, so we decided to do a little experiment.
The next Monday we took the pH and it was dark blue.
We didn't have the colors of the pH, we had the colors of cotton candy.
We decided that this would be our project. We took the pH manually and electronically and recorded the data on graph charts.
That's when the problems began. When we looked at our data, we figured out that there was no scientific connection whatsoever between the pH and the temperature, and that was our whole project. Even though we failed to figure out exactly what was affecting the pH, we learned two things along the way. The first thing we learned was that we had a theory that the reason the aquaponics tank's pH was changing so much was that we saw people sticking their hands and other items into the tank. We also learned that plants are very delicate, and if the pH that the plants are living in are even a little bit too alkaline or acidic, above or below 7.0, then the plants can die. Alkaline would be the pH of baking soda, and acidic would be the pH of lemon juice or Coke.
We hope that our project can help others to understand the importance of pH in the greenhouse systems. James, Jaedyn, and I all work together to make our project the best it could be. We hope that after people see our project, they will pay attention to the pH in their systems. This project can help somebody who wants to grow plants. The pH will help them know what they need to do to help their plant. Plants die very easily, but people think it's from overwatering or not enough sun. It might be the pH. This project will hopefully help people to try to maintain their plants' pH. People are going to need to start growing more plants in the city because there's no way they can feed all the people in the world with just a few farms outside of big cities.
That means that people are going to have to start building more greenhouses, which also means people are going to start using the pH more and more.
If we would do our project again, we would have taken pictures of what we saw in our data every Monday. Our favorite thing while doing our project was the surprise of the color of the pH fading in. We never knew if the color would be green or yellow or even purple. We hope you enjoyed our project and it helps people with the world of planting.
Thank you for listening.